Now we're going to think about two kinds of heat that you will need to think about if you are designing an air conditioning system or a refrigeration system. Sensible heat is heat that you can sense. You can measure it with a thermometer. Heat can raise the temperature of something, changing its sensible heat. But the other thing that can happen is heat can change the state of something from ice to water, from water to steam, from water to ice. That's latent heat being exchanged. So sensible heat is what you can sense. It's what you can measure with a thermometer. And sensible heat can be transferred with conduction, convection, or radiation. Latent heat is the energy involved in changing the state of something. And state means it goes from solid, like ice, to liquid, like water, or from liquid, like water, to gas, like steam. Latent heat is a way we can store energy and transfer energy, and that's why it's so important in refrigeration systems, which includes air conditioning systems. When a solid melts and turns to liquid, like a piece of ice melts and turns to water, sensible heat that was involved in melting the stuff gets stored as latent heat. And when water turns to steam, sensible heat gets stored as latent heat. It takes a lot of energy to break those molecular bonds between those water molecules and turn them into a gas. And then if a gas condenses, like let's say the steam condenses down and turns back into water, it gives off, it releases that latent heat. Well, this comes into play on a hot day if you're sweaty, and sweat evaporates from your skin. What you are feeling there is the latent heat of vaporization. It takes a lot of energy, a lot of BTUs, to transform that water on your skin into water vapor. And where does that heat energy come from? It comes out of your skin, and your skin feels cooler. So looking in the upper left here, it takes 1 BTU to raise 1 pound of water 1 degree Fahrenheit, as we discussed earlier. So here it's 32-degree water, almost freezing. To raise it to 33 takes 1 BTU. But over here on the right now, if you have a piece of ice at 32 degrees, 1 pound of ice at 32 degrees, to melt that 1 pound of ice, to change its state to liquid, even at the same temperature, takes 144 BTUs, a lot more energy. Looking in the bottom of the screen, if you have water that's almost boiling, it's 211 degrees Fahrenheit. It takes 1 BTU to raise that pound of water 1 more degree to 212, and now it's boiling. Now, let's take, in the lower right corner, let's take that 1 pound of water. It's at 212 degrees Fahrenheit. It's just on the verge of boiling. How much energy does it take to change that 1 pound of water to steam and leave it at the same temperature? It takes 1,000 BTUs. So that's the power of latent heat.